There are lots of things we can do to be nice. Sometimes they're hard to remember. But there are two little things you should never forget from January through December.
He's talking about please and thank you. They're called the magic words if you want nice.
So we have our Beta 3 notes, which is inverse functions and relations. First definition, inverse relation. Two relations are inverses if and only if one relation contains the element xy whenever the other relation contains the element yx. Now hopefully you're thinking to yourself, where have I seen this before? xy and then yx. Here's where you've seen it before. You've seen it when you were trying to find a symmetry about the line y equals x. Remember, you made x, y, and yx. It's the same situation. Two functions are inverses if they're symmetric with respect to the line y equals x. It will be a mirror image on both sides of that line of symmetry. Horizontal line test. This is the same thing as the vertical line test. Let me give you a visual here. Let's say that we have this curve. This is a parabola, y equals x squared. If we graph its inverse, it's reflective of the line y equals x, which is this line here. This is what that graph will look like. It's the white graph reflected over the line y equals x, and it gives you that yellow graph. We just label this, the inverse of this, we'll find out shortly, is plus or minus the square root of x. So if you remember the vertical line test says that if you can take a vertical line, right now I'm just looking at the white curve, if you can take a vertical line and pass it over the curve and it only hits it at one place at a time, it's a function. Notice this white only hits it in one place at a time. Notice the yellow, though, the inverse, hits it twice, so the yellow is not a function. That's what the horizontal line test says. If any horizontal line drawn on the graph of a function passes through no more than one point on the graph, then the function has an inverse that is also a function. So basically what it's saying is, if the original function, the white one, if it doesn't pass the horizontal line test, that means its inverse won't pass the vertical line test. That's what that's saying. Example A. Find the inverse of each function. There's directions over here on the right that tell you exactly how to do that. It's the same thing that we had done in a previous section. We interchange x and y. Then you simply get y by itself. Once y is by itself, then that would be the inverse of that function. I'm going to subtract a 9 from both sides. Then divide each term by 4. And you get a fourth of x minus 9/4. And finally, instead of writing a y, we typically, for the inverse, write f of -1, which just means f inverse. Number 2, please stop this video for a moment and try number 2. Once you've completed it, then come back and either watch quickly or watch slowly to see how it should be done. So if you interchange your x's and your y's, pardon me, that would be x equals 0.02 y minus 6. Then you get y by itself. Add 6 to both sides. We got this 0.2 times y. Now to get y by itself, you could divide both sides by 0.2. That's mathematically correct. But you're likely, if you do that, you're going to have to pull out your calculator. I don't want to pull up my calculator. What can I multiply both sides by to get rid of this 0.2? In other words, what can I multiply by 0.2 to get 1? And that is 5. So I can multiply both sides by 5 each term, get 5x plus 30 equals y. So the inverse I am just chock full of vitamins today. The inverse would be 5x plus 30. Let me give you another reason real quick why multiplying by 5 works. 0.2, as I read it, is not the proper way to read it. The proper way to read it would be to say 2/10, which means 2 over 10. That reduces to 1/5. So you're multiplying 1/5 times y. To get rid of it, you multiply by the reciprocal, which is 5 once again. Example B. Find the inverse of each function. Sketch the function and its inverse. Determine if the inverse is a function. Circle yes or no. So the first part of the instructions. Find the inverse of each function. That's direction number 1. Same thing we did for example A. Interchange x and y, then get y by itself. I would subtract x from both sides, subtract 2 from both sides, and I would square root both sides. When you do an even root, you get plus or minus. Therefore, the inverse is, the inverse of f is plus or minus the square root of x minus 2. Is this a function? You can determine this now, or you can graph it and then determine it. It's definitely not a function. Second part of the directions. Well, I guess I'm doing this in different order. What I just did is this part right here. Is it a function? And it's not, because if I put a number in for x, I'm going to get 2 answers for y, a positive answer and a negative answer. Those to sketch the function and its inverse, this should require little to no work for you. The original function is y equals x squared plus 2. The parent graph for this is a parabola with a vertex at the origin. This plus 2 takes that graph and translates it up 2. Therefore, our function, the original function, should look like this. It has a vertex at 0, 2. This is y equals x squared plus 2. Second part, how do we graph this? We don't have a parent for that. You do have a parent for it. The parent for this is, once again, y equals x squared, which looks like this. So how does that relate to this? Well, if this function is an inverse of that parent graph, and it is, because we just found it to be that, the first thing that you do is your reflections. Pardon me. The first thing you do is stretching and shrinking. Then you do your reflections. There's no stretching or shrinking here. Our reflections for this problem, an inverse is reflected over the line y equals x, as we previously stated at the beginning, inverse relations. Notice y and x get changed in their location, symmetric with respect to that line. So if this is our line, y equals x, you don't technically have to draw this part when you do your homework, tests, or quizzes. The reflection of this parent graph, which was here in red, I'm going to erase this, what's in red, so don't draw that. Its reflection would be what you see here in green. And then what does the minus 2 to the graph? What translates it to the right 2? So let me backtrack here a moment. Let me undo these pictures and just actually do what the problem said to do. So once again, since this is the inverse, it's reflected over the line y equals x. So it's right, like this. And then since there's a -2, it translates it to the right 2, which puts us the vertex at 2, 0. Now the vertex should be easy, even without doing any of the things that we just did. An inverse replaces x for y and y for x. This vertex was 0, 2. Its inverse would have a vertex of 2, 0. You interchange the x and the y. So this here is y equals plus or minus the square root of x minus 2. And once again, we can see that the function is, the inverse is not a function for two reasons. One, this green graph does not pass the vertical line test, as we learned earlier. And two, the original function does not pass the horizontal line test. So this question, once again, is it a function that's referring to the inverse? That's what the direction said. Question 2, same directions. Find the inverse. To find the inverse, I have to interchange the x and y values. Then you have to get y by itself. Opposite of cubed is cube rooting. Cube rooting the right just gets rid of the cubed, so you get y plus 8. If I then subtract 8 from both sides, I get this. So this is the inverse of the original function. Is this a function? Well, it definitely is. Let me show you why. Do not draw the following. I'm going to show you some things and I'm going to erase it and start over. The parent graph of this original function, if you take away the 8, it's just y equals x cubed. So once again, I'm going to erase this, so don't draw this. Y equals x cubed. Hopefully you recall that the parent graph is like this. It's two halves of a parabola put together. Vertex is at the origin. I want to show you what the inverse is going to look like. The inverse, once again, is reflected over the line y equals x. So the inverse of that is going to look like this. This yellow curve is y equals the cubed root of x. The white curve is y equals x cubed. So when this says minus 8, as it says there, this yellow curve is going to go down 8 units. If you look at the original function for this problem, there's a plus 8 inside the parentheses. That means this white curve is going to go to the left 8 units. Alright, so let's officially draw this now. So it's graphing the original function, which was y equals the sum of x and 8 cubed. It's this curve from the parent, and it's translated left 8. So the vertex is at negative 8, 0. And it looks a little something like this. The inverse of this is reflected over the line y equals x, so it's going to have this shape. And then we can see here there's a minus 8 in it, so it takes the whole thing and translates it down 8. Picture is far from perfect. If my picture were perfect, and it's not, wherever these two curves intersect, that should be on the line at y equals x. Looking at this diagonal, if you could physically fold your paper or your computer screen in half, it should be a mirror image on each side. It's not, because I didn't do it perfectly. Just get it as good as you can. Notice the curves. This is curving away from the line of symmetry. This is curving away from the line of symmetry. You have to do that part right. And then here it's curving in towards and then up. Here it's curving in towards and then up. To the right, I should say. So this is y equals the cubed root of x minus 8. This vertex, I went down 8, so it's a 0, 8. The only thing else to do is find the y and x intercepts. Let me show you how sweet this is. This is just phenomenal. There's no room to do any of this work, which I apologize for. I'm going to cheat a little bit. I'm going to cheat a lot. Make that some smaller. So to find the, did that say y cubed? That's not supposed to say y cubed right there. That's supposed to say y cubed there. Hope that didn't cause problems. That should just be y. Shouldn't have been cubed. Anyhow, to find the y-intercept of this white curve, which we haven't done yet, simply put 0 in for x. Zero plus 8 is 8. 8 cubed is 512. So the y-intercept for the original function is 512. You can see in my picture I can't see that, so I'm just going to write it 0, 512. If that's the y-intercept for this function, what does that make the x-intercept for the other function? We'll just take this 512 and the 0 and you flip them around and you get 512, 0. The x-intercept for this inverse, you just switch the points around. Any point that's on one graph, switch the x and y around to get a point on the other graph, which leads me to a mistake that I wrote right here. I went left 8 and 0, so this should be 0, negative 8. I went the right direction but didn't label it correctly. So is the inverse a function? Yes. Passes the vertical line test, and the original function passes the horizontal line test. Part C. For each parent graph, describe the transformation or transformations that have taken place in the related graphs of each function. And then it mentions here on the side once again, do dilations first, reflections second, transformations third. So number one, we got f of x is x cubed. You should know what that looks like, although it doesn't matter for this problem because you're not actually graphing it. It looks like this. So part A, if you look, this is the cubed root of x, where the parent was x cubed. This is the inverse. If it's the inverse, it's reflected over the line y equals x. It's the same as the parent, but it's reflected over the line y equals x. So instead of being like this for this problem, this one here is this, like so. B, it's that same inverse, it's a cubed root of x, so it's reflected over y equals x. This plus 3 translates the graph up 3. It's the same translations, same rules that applied to the previous notes where we talked about families of graphs. If you don't remember that, go check out that video. It's families of graphs. I forget what beta number it was, but C, once again, it's the cubed root, so it's reflected over y equals x. And then this minus 16, it translates the graph right 16 units. Part D, at this point you probably want to stop the video, try a couple of these on your own, and then restart it again. You can do that at any time. Just stop the video, try something on your own, and then see what happens. I encourage you to do that. D would be reflect over y equals x. This minus 2 goes right 2, the minus 6 goes down 6. So we say translates left 2 and down 6. E, we've got a couple of reflections here. We have the inverse reflection, so it reflects over the line y equals x. And then notice, can't see it very well on my screen here, but there's a negative symbol here. The best way to make this more visible, it's a negative in front. If you recall, multiplying the function by a negative reflects the graph over the x-axis. So to show you what that looks like, this graph up here, once again, reflected over the line y equals x. If you then reflect it over the x-axis, after that reflection, it's going to look like this. So this blue graph has been reflected 2 different times. The order that you do the reflections doesn't matter, but you have to do those before you do your translations. Then this minus 3 in the parentheses, technically there's parentheses in here even though you don't see them. We translate to the right 3, and then this plus 8 we translate up 8. Right 3 and up 8. That's it for C. D. Supposed to graph the 2 relations on the same screen. Determine if the 2 relations are inverses. And then if they're not inverses, find the inverse of the first equation. So to graph this, we're going to go to the y equals. We're going to type in this first function. And I'm going to have to make this a little bit smaller. Pardon me. Hopefully you can still see that okay. Let's try the middle size. See if that fits. That looks about right. So I'm going to put in parentheses x plus 1, parentheses, and then squared. Supposed to graph both these on the same screen. So then my second one, to my knowledge, there's no plus or minus on your calculator. So this second one you're going to have to put in twice. One where it's the positive version, and then in the other where it's the negative version. So make sure we follow the directions. Graph the 2 on the same screen so that it looks like there's 3 here, but there's 2. Because these last 2 are combined to get plus or minus. To determine if the relations are inverses. So let's hit graph. Let's check it out. If we were to take this screen, let me change my window here a bit. If I hit the zoom button, and if I select square, that makes the screen square. So that pictures are to scale. It's not being stretched at all. So if I look at this, if I draw an imaginary line y equals x here, would these 2 graphs be mirror images of each other? No, they wouldn't be. So that's the first question. Determine if they're inverses. No. If it's no, write the equation of the inverse of the first equation. My first equation is y equals x plus 1 squared. So to find the inverse, we interchange the x and the y. Square root both sides. Subtract 1. So we're saying that the inverse, so I'm saying the inverse for this original function is plus or minus the square root of x minus 1. And I forgot, we should graph this as well. We should graph the two functions we just had in our calculator. I could bring this back up here. This curve here should be able to tell what my vertex is. The original graph went left 1, so the vertex is 0, 1. Pardon me, 0, negative 1. If you want to find the Y-intercept, you should be able to tell just by looking at it. If you can't, then here's how you can ask your calculator. Hit second, calculate. We want to find the Y-intercept. The Y-intercept is when the x value is 0. So we select the first one option, the value. Now notice it says x equals, so we put in a 0, and it tells us that it's 1. If I go to my second, if I hit up or down, every time I hit up or down here, it changes from one function to the other. So this has a Y-intercept of 1. If I hit up to go to the other function, it tells you here what function you're on. There's no Y-intercept because it says x is 0, y is, don't know what it is. So this is 1, let's label that. And the other function, it's the inverse, so it's reflected over, it's the inverse of the parent graph, not of this specific graph. So it's reflected over a line y equals x, so it looks like this, and the plus 3 translates it to the right 3. Not sure why we need our calculator for this, but the directions say to, so we're going to do that. And there's no Y-intercept for this. So that's 1. Number 2, I'm supposed to graph these on the same screen. So it's x squared minus 2. And here we get plus or minus x plus 5. So we got to put this in twice, one for the plus and one for the minus. Check out our graph. Oh, maybe these are inverses. Let me throw those up here real quick. You can see what that looks like. Graph that, because I'm going to lose that image as soon as I start drawing here. I could cheat. Why don't I cheat? I'm going to cheat. Oh, there's my graph. Awesome, blossom. Something I forgot about number 1 here, I should have labeled this y equals x plus 1 quantity squared, and y equals plus or minus the square root of the difference of x and 3. So I need to label all these points. Let's just ask our calculator. I'll show you how to ask them, and then I'll transfer them over later. So we got this graph here. What is its vertex? It's obviously negative 2 because you can tell, but let's just see what the calculator says. Hit second, calculate. This time we want to select a minimum. It's the lowest point on the graph, so I hit enter. Notice it tells you what function you're on. We're on x squared minus 2. If you want to change the function, you just hit down and it goes to a different function. We want to do this one. Left bound, this cursor needs to be to the left of your minimum. Any place to the left. That is to the left of the lowest point. Hit enter. It says right bound question mark. Move the arrow to the right so it's on the right side. Hit enter. Then the calculator says, would you like me to guess what the answer is? It's really reassuring. So I hit yes. It says a minimum is negative 2.721 e to the negative 6, and y is negative 2. Well, here's a little something for you. And that is that this right here is really 0. E to the negative 6 is scientific notation. So we take this decimal point, move it to the left. 1, 2, 3, 4, 5, 6 times. Keep in mind that your calculator said, do you want me to guess the answer? So it guessed the answer was this real small number. And it's actually 0. As you can tell by looking at it, it just goes down 2. So this vertex right here, this minimum, is 0, negative 2. This has 2 X-intercepts. To find out what those X-intercepts are, once again we ask our calculator. So we say, second, calculate. I want to know the 0 of my graph. So I hit enter. It says left bound. This cursor needs to be to the left of that X-intercept. I'm going to try to find this one right here first. Hit enter, and then it says right bound. Move your cursor to the right side. Move it to the right. I hit enter. Then it says once again, hey, you want me to guess? I'm a calculator and you're a person and I'm supposed to know the answer, but I don't, so I'm going to guess. Hit enter. Hit negative 1.4, we'll say, to the nearest tenth. So this X-intercept's negative 1.4. Do the same thing for this other X-intercept. You're going to find that it's positive 1.4. I'm just going to transfer these answers over here real quick. So we got an X-intercept of 1.4 and an X-intercept of negative 1.4. And we had a minimum here of negative 2. Other points, we have 2 Y-intercepts here and an X-intercept. Let's figure out what those are. This is not as simple because we had to graph 2 different parts to get this, so let's see what happens here. So second, calculate. I'm going to find the Y-intercept. So I'm going to say, what is the value when x is 0? Hit enter. Now it says negative 2, but that's this curve we already found. We can tell it's that curve because it says it here. If I hit down, it's saying that's 2.2. If I hit down again, it's saying a negative 2.2. So we have y-intercept 2.2 and another y-intercept of negative 2.2. And I just wrote that wrong. 0, negative 2.2, not negative 2.20. Now I'm just missing this point here, which is an X-intercept. Let's see if we can get this to work. Second, calculate. When I select 0, it doesn't work. Right now I'm on the wrong curve. I hit up or down to go change my curve. It says left bound. If I move this to the left, I can never get it to the left of that X-intercept. Just by eyeballing it here, it looks like it's real close to negative 5, which of course it is because this graph was moved to the left 5. So calculator is really not that helpful for that part, but your brain is very helpful. So next question, are the relations inverses? A lot of things going on in this picture. Looks like it has the potential to be, but they're not. Here's the dead giveaway that they're not. this x-intercept for this function should be the y-intercept for this function. And it's not. This x-intercept is -5, this y-intercept is -2.2. Remember, inverses, if you change the x and y value, that point should be on the other graph. -50 is not on this other graph. Another reason, if you were to visualize the line y equals x, which is something like this, if you reflect this first graph over that, it's not going to be where the second graph is. So are they inverses? No. If no, inverse, and the direction said the inverse of the first function, y equals x squared minus 2. Interchange x and y. Get y by itself. This is the true inverse of that original graph. Did not give myself much room here. I apologize for that. Finally, the third one. I'm not going to use my calculator for this. It's just too easy. It's too simple. Directions said use a calculator. I say phooey on the calculator. I know what this parent graph is. It is the cubic function. This -6 translates it down 6. So it may look something like this. 0, -6. This one here is reflected, it's the inverse of the parent of x cubed. So it's reflected over the line y equals x, it looks like this. And that +6 translates the whole graph up 6. So this is y equals the cubed root of x plus 6. This one is y equals x cubed plus 6. Are they inverses? No, two reasons. One reason is hopefully obvious. If I make this line y equals x through here, these graphs are not symmetric with respect to it. An obvious reason is wherever one of these curves hits this line of symmetry, the other one should hit in the exact same spot. My picture is not perfect, obviously, but there's no way it's that far off that this is hitting it in this location and this one's clear over here. Another reason is we didn't find the x-intercept of this graph or the x-intercept of this graph. Let's find that real quick, and you can ask your calculator. I'm not going to, because I'm that sweet. You're allowed to though, because the directions say to. Find the x-intercept of this graph here. I'm going to put 0 in for y and get x by itself. It's a cubed root of 6. So this right here is cubed root of 6, 0. This x-intercept over here is negative. It's not even close to being what this one's going to be. So these ones are not inverses. Comparing the x and y intercepts. This x-intercept, if I put 0 in for y once again, I subtract 6 from both sides and then cube both sides. -6 cubed is -216. So this x-intercept up here is -216, 0. So big picture once again looks like this, not inverses. If it's not an inverse, what is the inverse of y equals x cubed minus 6? What the directions say. interchange x and y, get y by itself. It's the cubed root of x plus 6. Which I have a little to no room to write this. So I'll just do this.